Hi, I'm Courtney Nash. I'm an editor with O'Reilly, and I am here today with Garrett Grolemund from R Studios. Welcome, Garrett.
Thank you, Courtney.
And we're here today to talk about R as a programming language. We'll talk about more than that, but that's what I want to start off with talking about. So why don't you, for people who might not know what R is, why don't you give a little bit of background on what that is?
Well, R is a programming language that's been around for at least 20 years now. It has its roots in a language developed by the AT&T Bell scientist named S+. And R is basically a free version of that with some minor adjustments. That's now an open source programming language people use to do data analysis and statistics. And it's quickly becoming the lingua franca of data analysis.
So talk to me a little bit about, obviously there's other ways you can do data analysis in the world. Existing things that academics and other people might know very well, like SAS or SPS. What does it mean for R to be a programming language for data analysis versus, say, just a data analysis tool?
Sure. Well, in a lot of programs that people use to analyze data, such as SAS or SPSS or even Microsoft Excel, statisticians, people who work with data, have gone through the trouble of programming procedures that you might want to do to the data, and they exist there in your program. And then when you're ready to use them, you can pull them off the shelf and apply them, and then whatever results they give you, you can work with. R, because it's a language, you have a little more control over that. Instead of using something that already exists, you could use the components of the language to write your own methods for analyzing data, which is very handy because a lot of times when you want to get information out of data, how you go about it is going to depend on the type of data you have. Even down to details such as, what does your data set look like? What missing values do you happen to have? What shape is it in? So to have the freedom and the flexibility to do what you can imagine to your data just opens up opportunities that don't exist when you're constrained to use the tools that already exist inside of the computer program.
So when you talk about, sort of writing your own method for data analysis, something specific to what your needs, can you give a more specific example of something like that? Or maybe something in your work that's an example of that?
Well, I guess this might be a little general, but yeah, my background is in statistics. I graduated from ICE with a PhD in statistics. And in the academic field of statistics, people come up with new methods for analyzing data, every day. That's their career. And normally these new methods get implemented first in R because if you're developing something that hasn't been done before, you can't rely on something that already exists. You need to put it together yourself. And R gives you the tools to do that. So, there's many different arcane methods out there, but something that's been very useful has been like lasso penalized regression methods for creating models and doing variable selection on data sets where you have many variables and not as many observations. And these things were implemented almost immediately in R, and they still exist in R for people to use. And they're slowly making their way into other languages because you have to wait for the company that maintains SAS or the company that maintains SPSS to get around to doing it and testing it and making it available to you as a user. But many of the academics who make these methods implement them in R right away so they could get out there, they can start being used, and the academic can start getting feedback, that they could use to.
Right. So, and it's a bit of a funny thing I wanted to point out because we're talking about R as a language, and when you use the word method here, you don't necessarily mean what somebody who's a programmer means by method, do you?
No, I guess I don't. So, the methods I'm speaking about are statistical methods of, making inferences based on data, quantifying uncertainty and working with probability. They're more mathematical, statistical things.
Right.
And that's really what R is meant to do. It parallels so well what you want to do to data, but it's the computer version of that. I think that's why it's catching on.
Well, you sort of asked my next question for me, so I'll expand on it a little bit. But what is it about R that's so useful as a language for data analysis? Or is it just that it's like a programming language and that happens to be useful?
Yeah, that's a good question. It is useful because it's like a programming language, and now it's come to a certain critical mass where statistical methods, go-to methods that you might want to use, or even arcane methods that you've only heard once or twice, have already been featured in R, so you don't have to start from scratch to use them. You could use what's already there. It's open source, so as you may imagine, passionate community has developed around it, and the people in this community, to be honest, I think most of them have a 1 foot deeper into statistics than they have their other foot into programming. So you find all sorts of interesting statistical things pre-made for you to use in R. And so if you want to extend those or push the ball a little further down the line, you can already stand basically on the shoulders of giants and use what they have and just put your methods on top of that. So that's a useful feature. But then if you look at the language itself, it makes it very easy to extract pieces of data sets, to extract observations and variables, the sorts of collections of values that as a statistician you find meaningful and that you need to use to extract information that's in the data set, but it might not be immediately apparent when you look at the data.
Can you talk a little bit more about the guts of that, about what it is about R specifically that really helps you do that? Or
well, it uses a notation that's very similar to what you'd learn in linear algebra if you were coming up through mathematics and statistics. So intuitively, it makes a lot of sense if your background is in anything that uses data. And then from the computer side of things, R is a functional programming language, which is pretty straightforward. You don't have to be too imaginative to understand what it's doing, see what it's going to do. But it also has some object-oriented programming bits. So you could take advantage of method dispatch and creating behaviors that depend on the class of your data, which is very useful in different situations. So you have a little bit of both going on there. And then R is what we call like a vectorized programming language, or it handles array programming. So most R functions don't take just a number, but they can handle a whole vector of numbers. And then they can return a vector of numbers as well. And that sounds fairly simple, but when you pair that with data analysis and what you do with data, you're almost always working with a collection of numbers, be that the distribution of a variable, all of the values will be stored as a vector, or is it one observation of different measurements? You could put those together in a vector as well. So R kind of saves you from a lot of data munging. The data structures it expects are the data structures you are using anyways as a statistician. And I think that's, that makes it easy to use R to do what you want and to avoid headaches, which appeals to many people.
And when you talk about, I kind of want to come back to the functional programming piece a little bit in a minute, but when you talk about object-oriented languages and munging data, the first thing that comes to my mind is Python. I know a lot of people use Python to deal with data. Are those, I don't think we're talking about mutually exclusive things here in terms of R and Python. Maybe you could play a little compare and contrast or talk a little bit about what you're seeing, in the data analysis world with regards to how people are using R and or Python.
Sure. I don't use Python very much myself, but people are very passionate and loyal to Python, and people are starting to use Python to analyze data. I think R has a bit of a head start on that. R was invented to help you analyze data. Python was invented to be a programming language that has a lot of good features, but its tools for analyzing data just aren't as mature yet as they are for R. However, people are working on changing that. But at the same time, I think both programs are kind of growing exponentially in terms of what's available to you out there, what people are doing, and it's just so hard to catch up to R, which is already accelerating on its own. These days we're doing things with R such as creating interactive visualizations and web programs and things that you just wouldn't really have expected from a scripting language that's originally designed to manipulate numbers and affect matrices. I do want to make one point though. It's very easy to combine languages. There are many R packages, which are kind of equivalent of Gym and Ruby or that sort of thing, that help you call Python functions inside of R, and also vice versa. And then even if you look at the commercial programs such as SAS and SPSS that you might think of as R's competitors, they all try to make it easy for you to use R programs inside of SAS or inside of SPSS, because these companies recognize many people are out there using R, and there's a lot of interest in using it. And they want to make sure you could do that while you still pay them for their program.
So my last question was going to be a bit more about folks. You mentioned a lot of people come into this more from statistics than from a programming background. So if somebody wants to start using R for their own analyses, is there a big hurdle to getting going with that?
No, not at all. If you've never used a computer programming language before, you could use R. It's no more complicated than using like a TI-89 graphing calculator. You're just saving things to symbols and then putting symbols into functions. And in fact, a lot of people learn R without knowing any computer programming skills. And they use it for the longest time thinking it's just a fancy calculator that runs on the computer. And it might only be later that you realize it's a whole programming language and you can write your own functions to do, whatever complicated or sophisticated or personalized thing you conceive.
Great. Well, thanks for chatting with us about today, about R today. I will talk a little bit as we close up. You've got a book going, I believe, that you might want to say a little bit about here at the end.
That's right. I'm writing a book called Data Analysis with R to be published by O'Reilly, and it focuses on how to do data analysis using R as a computer language that implements the techniques of data analysis. So one thing that happens is when you work with data, you just can't do it in your head, and you can't really do it on paper or pencil either. You need a computer language. And since R has so many insightful ideas that were built into it to make it easier to analyze data, you might as well use R, take advantage of those things. And my book focuses on how you can do that.
Great. And that will be out later this year. I'll be intentionally vague about that to spare you any torture on the exact date. And I just want to say thanks again for joining us today to talk.
Thank you, Courtney.